Okay, so now we're going to talk about modular arithmetic and equivalence classes. So here we will, modular arithmetic is, so we have x mod b if x is equal to c b plus y. So basically, if to give you guys a concrete example of what this means. So to give you guys something more concrete here, let's say we want to look at what is 57 mod 32. So here I would look at 57 is equal to c times 32 plus whatever my actual answer is. Sorry, this right here is congruency. We don't actually say equal, we say congruent, and we use this triple equal instead of this double equal. I'm not going to nitpick on that. It's something that's important on a theoretical level, but it's, I think for our purposes, just kind of more annoying to deal with than it's worth. This is actual equals plus whatever the remainder is. So we would do 32 or 57 divided by 32. So that's going to be equal to 1 plus 25 over 32. So this is 1 remainder 25. And this c is 1. I don't really care what that c is because when I'm doing modular arithmetic, I don't actually care that much usually if this was 52 versus 89, which would be the next thing that's equal to 25 mod. So we get 57 is equal to 25 mod 32. And it's also equal to 89 and plus another 32. And it's also equal to 25. And we can do this for negative numbers, so it would be also -7. So you can keep going in either direction. So it forms an equivalence class. Any of these guys going off to infinity, so that's 25 plus 32z, forms an equivalence class under this. So if I have two numbers a and b, then so a plus b mod c is equal to a mod c plus b mod c. All this mod c. So if you go over c, then you just circle back. And the reason for that is a is equal to, call it xc plus d, and then b is equal to yc plus e. Therefore, when I look at this guy, I get x plus yc. So this is a plus b is equal to x plus y c plus d plus e. So this is a multiple of c. So that tells me that it's d plus e mod is congruent to d plus e mod c. And then the same deal here. A is equal to x c plus d. So a mod c is congruent to d. B mod c is congruent to e. So a mod c plus b mod c is going to be congruent to a plus b. So we have a notion of addition still. We also have a notion of multiplication. So if I have, instead of adding them together, if I did A times B, then what I would get is XC plus D times YC plus E. So then that becomes XYC squared plus DXC plus EXC. Sorry, the D should be attached to YC plus DE. All of these guys are multiples of C. So when I do the modular arithmetic, they're irrelevant. So that's D mod C. And again, this might not be the most natural way of representing it. So I might have to subtract a multiple of C to get it within the range. We normally write things between 0 and C minus 1, but we don't have to, because if I were to have, if I were to write 57 mod 32, that is equal to, or congruent to, 25 mod 32. This is just the more natural way of writing it. But this is also valid because these guys are in the same equivalence class. So you basically have two different methods of writing your answer.